Pokemon, gotta catch 'em all. 11.9, Binomial Probability. As you have noticed, we've already done 3 lessons on section 11.9, just because it's kind of an important section. It covers a lot of stuff, so I split it up into 3 different sections. This one being the last of it, Binomial Probability. All right, so this formula should look a little bit familiar to you guys. It was introduced last the last time we did a video, and it was to help expand binomials. And so we're going to use the same one to do some probability. All right, for probability, we're going to have the P stand for the probability of successes, the probability of what we want. The Q is the probability of failures. N is the total number of trials, so how many times we're going to do this. And then X is the number of successful trials, and so how many times we're going to do this that were successful or that what we wanted. All right, so that's what all the letters stand for in the formula. Let's do an example. All right, so we have the first part of the homework. They basically give you all the information, and they want you to just plug it into the formula to get familiar with using the formula. So find the probability of X successes in N trials for the given probability of success P on each trial. All right, so they give you, here's the formula up here. They give you 3, which is the number of successful trials. The N is the number of trials all together, and then P is the probability of success per trial. All right, so they give you all the information. All you got to do is plug it into the formula. All right, so notice the N up here is the total amount of trials, which in this case is 10. The X is the amount of trials that were successful, which is the 3. Well, they don't tell you this part, but it is N minus X. It's basically the total number of trials minus the number of successes, because it stands for the failure part. So if we had 10 total and 3 were successful, that means 7 must be the failure part. There it is. And then this part, this P, is the probability of success. In this case, it's 0.25. They give it to us right here. And then how many times was it successful? 3 times. That's the one we wanted. And then this part, if 25% was successful, that means 75% must have been the probability of failure. And then how many times does that happen? 7 times. It matches this one right here. All right, and you just punch all of that into your calculator, and you should get approximately 0.2503. All right, let's try another one of those. Just using the formula, plugging it into certain parts to get the right answer. X is 5, that's the number of successes. N is 7, the total number of trials. And then P is the probability of success. And plug it all in. There's the 7. There's the successful trials. That means 2 of them must be failures because there's a total of 7. And then here's the probability of success, 5 times. And then because the probability of success is 0.33, the probability of failure must be 0.67 because it's supposed to add up to 100%. And that happens twice. Punch it into your calculator. See if you can get that. All right, now let's apply it to an actual problem. As part of a promotion, a store is giving away scratch-off cards. Each card has a 40% chance of winning a prize. Suppose you have 5 cards total. Find the probability that exactly 4 of the 5 cards will reveal a prize. All right, so the probability of success is 0.4. That's the 40%. The total number of trials is 5 because you have 5 cards in your hands. 4 is the amount that you're hoping to get. Exactly 4 of the 5 should win that you want to win. So let's go ahead and plug all of that into the formula. Again, that's the total amount of cards you have. This is the amount you want to win, exactly 4. That means one of them will be failure. There's the probability of success, 0.4, and we want 4 of them. That means the 0.6 is the probability of failure, and there's only one of those. Punch it in your calculator. You should get 0.0768. All right. Now, the next question. Find the probability that at least 3 of the 5 will reveal a prize. So we want 3 of the 5, or at least 3 of the 5. So what does at least 3 mean? That means 3 or more. So basically 3 or 4 or 5. So here's the applying the formula for 3 wins. This should get about 0.2304. Here's the probability of getting 4 of the cards to win. We already got that answer. And then here's the probability of at least getting 5 of the cards to win. There it is. So at least 3 means 3 or 4 or 5. So you have to do it for all 3. And then once you get all 3, add them up. And then that's the probability of at least 3 out of the 5 will reveal a prize. 0.31744. All right, here's another example. There is a 75% chance that the coach will pick a player to start the game. Of the 20 players on the team, what is the probability that exactly 9 players will be picked to start? All right, so P, the probability of success that you will be chosen, 0.75. There are a total of 20 players. I want exactly 9 of those players to get picked. All right, plugging it in, you should get 0.0030. Next question. What is the probability that at the very most 9 players will start? So at the very most means 9 or less, which means you have to do the equation for 9 players, and then you have to do it for 8 players, and then you have to do it for 7, 6, 5, 4, 3, 2, 1. So you have to do that formula for all of those numbers, then add them all up, and that's the answer. There's the answer. What about what's the probability of at least 7 of those players will get started? At least means 7 or more. So you have to do the formula for 7 players. Then you have to do the formula for 8 players, for 9, for 10, 11, all the way to 20. Oh, the 20 is actually blocked by my face, but there's a 20 there. So you have to do the formula all these times and then add them all up, and then it'll give you the answer of 0.9999. Now, that's actually a lot to do. You have to do that formula over and over and over again until you get all of them, and then you add them all up. That's a little bit much. So your calculator will actually do it for you. If you look on your calculator, the VARs button is right here. But we don't want the button. We actually want on top of it the distribution button. So you'd have to go to second and then that button. Once you do that, you'll see a menu. It's actually, you have to scroll down a little bit to see this menu, but we are focused on these two right here. The binomial PDF and the binomial CDF. All right, we're going to use those two. To find the exact amount, so like that basketball question where I wanted exactly 9 players will be picked, you would use the binomial PDF option, this one right here, the PDF option. All right, once you click on the PDF option, it'll ask you for trials. That's the N, that's the amount of players there were, 20 total. And then it'll ask you for the P, the probability of success. You would put I forgot what the percentage was, but whatever the probability of success is. And then they'll ask you for the X. How many of those players do you want to be successful? And I think in this case it was 9, not 3. This was just a generic picture that I stole off the internet. And then once you paste it, it'll put in the numbers right here, and then it'll tell you the answer. It's pretty nice, huh? Oh, the N stands for the number of trials. The P stands for the probability of successes. The K, it wasn't K, it was X, the number of successes. Okay? And so you use that for the exact amount of successes. For the at most problem, all you have to do is go to the binomial CDF option, punch in the total number, punch in the probability of success, and then punch in the number that was at most. So if it was like at most 9 players, you would put 9 in there, and it'll do 9, 8, 7, 6, 5, 4, 3, 2, 1. It'll do it all for you. So that's kind of cool. And then of course it'll do the probability of at least something was going to happen. And this one is a little bit more complicated because before you even go into the distribution vars button, you actually have to put in 1 minus first. So do 1 minus and then do the button. Pick the CDF and then pick the number of successes, pick the probability of successes, and then 1 less. This is important, 1 less than what they wanted. So yes, 1 less than the amount that they want. And then push enter, and then you should have the answer. All right, so try these options on the homework. Actually, if you want to go back 1 slide and look at the basketball problem to make sure you can get the same numbers that I did, it's a good practice for using the calculator. All right, go ahead, try the homework and see how well it goes.